So, guys, a very good evening. And in today's session, we'll continue with looping constructs. So, yesterday we started with loops, like we have seen basic introduction to loops, and we have seen some programming examples also. And I made actually one of our student to write those programs because only she is available yesterday in the class. So, I just made her to write programs. So, in today's class, what I'll do is I'll continue with that looping construct. So, first of all, try to understand that when you are going to work with loops, when you are going to work with loops, see, whenever you want to execute some set of statements, say you have written like few statements here, like statement 1, statement 2, statement 3, statement 4, statement 5. Like imagine you have written 5 statements, and these 5 statements you want to execute it repeatedly. That's the thing, but continuously you want to execute it. Then what you have to do is you have to keep these statements inside. You have to make them in one block actually, and this block should be a looping block. So either you can work with while loop, or you can work with do while loop, or you can work with for loop. Any loop you can take it. And you need to understand that the loops are divided into two types actually. One is count control. Second one is condition control. So the count control loops gets executed for a specific number of times. So when you know in advance that how many times a task has to be performed, then always go with the count control. And for count control, the best loop is for loop. And when you don't know that how many times a loop has to be repeated, but you know that this loop has to be repeated till it reaches to a particular condition, then you can use either while loop, or you can use do while loop. And again, while loop is used for entry check. The condition will be checked in the entry level. Do while loop is used at exit check, because in do while loop the condition will be checked at the exit level. Okay, and we have seen some couple of programs in yesterday's class. We can just play the recording also. Now I'll explain you jump statements in C language. Jump statement, there are totally 3 jump statements are there. The first one is like a break, second one is continue, and the third one is go to. First, I'll explain you break and continue, and then I'll explain you go to. So whenever you use break statement, say suppose for example, you have written one condition and you have written break. So when you give break statement, what happens? The control will come out of the loop. It will exit from the loop. It will exit from the loop and it will never enter into the body of the loop again. But when you use continue statement, when you use continue, then what happens? The control won't come out of the loop, but it won't execute the statements which are written after this continue keyword. It won't execute those statements, and it will continue with the next iteration of the loop. Means it will continue with the next repetition of the loop, and it won't execute the statements which are written here below. So it won't come out of the loop, but it will skip the statements when that continue keyword encounters, and it will continue with the next iteration of the loop. So what we'll do is, now we'll see a program in C language to understand how exactly break and continue keyword works. And after that I'll tell you how this break and continue keywords will be implemented while writing programs. Okay, so now I'll I'll open 8 to 9 p.m. batch. Okay, I'll just use this program. Or what I'll do is I'll just create a separate file with the name like test.c, test. And we'll try to understand how the break keyword works. Now what I want to do is I want to write a simple for loop to print 10 numbers on the screen. So let me declare one variable with the name I. Now I'll say for I equals to 1, I is less than 10, and I'll say I plus plus. And I'll say printf slash n percentage d comma I. So when you run this piece of code, you'll get 1 to 10. Like you're not getting the number 10. Let me check because you're not giving equal to, you're printing less than 10 only. So less than 10 means what? Up to 9 only you'll get it. And I'm giving slash n at the end because uh, after completion of the program, it displays some message like execution time and press any key to continue. I want to display that message after giving one line of gap. So this is what simply printing 10 natural numbers on the screen. So guys, just let me know in the chat box. Is everyone is clear up to now? So simple concept. Nothing is there. Nothing is there. So simple concept. I'm just printing 10 numbers on the screen.
Clear, sir.
Yeah, thank you. Now what I want to do is, whenever the I value reaches to multiple of 5, means whenever the value of I perfectly divisible by 5, then I want to come out of the loop. So I'll write my condition here like this. If I percentage 5 equal to 0, means when the value of I is perfectly divisible, then I'll say break. Now in this case, what happens, initially I value is 1 and 1 is printed on the screen. It is not perfectly divisible with 5. So this break statement will not get executed. I plus plus will take place. Like this, whenever the I value becomes 5, 5 will be printed on the screen and loop will be terminated, means it will come out of the loop. So if you want to write here a message saying that out of the loop, you can write it here and you can simply run it. And you can see a message is printed saying out of the loop. Now listen, if you don't want to print the value of I, then you should give the print statement after the if block actually. The print statement you give after the if block. And if you are a beginner and if you have confusion, then what you can do is even you can use this floor brackets and you can keep this like this. This is known as if block. And this print statement is written out of the if block. Now what happens, like you'll get only numbers up to 4 and I becomes 5. As it is perfectly divisible, it will come out of the loop and 5 won't be printed. Everyone got clarity on this? Just let me know. Just let me know everyone got clarity on simple break concept. Nothing is there. So simple. You can just give your confirmation in the
Yes,
chat box. Thank you. Thank you so much. Now, what I'll do is I'll just change this break keyword to continue. Now, can you guess what will be the output of this program? Just let me know. What will be the output of this program?
5 won't be printed.
So you'll get 1, 2, 3, 4. Then 5 won't be printed. 6, 7, 8. Can I say 10 also won't be printed? Why? Because
Yes,
10 is also multiple of 5. Means it is not breaking the loop, but it is executing partially. After that, it is going back with the next iteration and it is continuing. So you won't get like 5 and 10 because 5 and 10 are multiples of 5. So Upender, is it clear? Upender, is it clear? Understood the simple basic
Yeah,
concept? Okay.
Yeah, yes, sir.
Okay. Anywhere in the middle, if you get doubt, you can just pause me so that I'll help you to clarify. Now, I'll explain you one more keyword that is go to, and then I'll explain you few programming examples. So here, what I'll do is I'll declare one variable with the name x, whose value is 1, or you can say initially it's 0, and I can say printf /t %d, comma x uh, plus x. Plus x means what? It will increment and then it will print the x value. Or if you say x equals to 1, then you can say here x plus plus. Then it will print 1 first and then it will increment the x value by 2. Here I'll write if the x value is less than or equal to 100, if it is x less than or equal to 100, the control should go back to the print statement. So I'll say go to, it should be followed by any label actually. So I can use any label name actually. There is no compulsion that I should use only this name. Okay. So I can say Upender. I can say go to Upender. So throughout the program, somewhere there should be a label with the name Upender followed by a statement. And it should be colon, not semicolon, it should be a colon. So this is known as actually label, a block of statement associated with a label. So what happens, when the program executes, x value will be 1. It will print this x value. The value of x will become 2 in the memory because you have written plus plus. And here x value will be compared. If it is less than 100, you said go to Upender. Then the control will be transferred, is it clear, back to the label where Upender is written. And then it will print the x value again. So guys, can you guess what will be the output of this program when I compile and run? Can you guess? Just try to guess and tell me so that then later I can help you. Or guys, can you see 1 to 100 natural numbers on the screen? But do we use any loop here? One sec. Do we use any loop? There is while, do while, for. So sometimes in interviews, they'll ask you some questions like this. Write a program to print natural numbers till 100 without using any loop. Then you can use like this. So here, any label you can write it. Like you can say go to hello. Okay, and this should be associated with hello. Any name of your choice, you can use it. So these are the totally 3 jump statements which transfers the control in the program from one location to another location. Is everyone is clear with this? Just let me know in the chat box. If it's clear, okay, very good. Now I have a small question for you guys. That is, can you tell me what do you mean by a prime number? Can you can unmute yourself and you can tell me that what do you mean by a prime number?
The number which is divisible by 1 and itself.
Very good. Or we can say the numbers which has only 2 factors. Am I right? Like what you said is correct. But in the other way, we
Yes,
can
sir.
say like this, the numbers which has only 2 factors. So suppose if I take one number, say x as one number. So where I can find the like factors of this x variable? I can find from 1 to till that x. Am I right? Means suppose if I take a number like 25, so how I can check the factors? I should start dividing this number 25 right from 1 to till 25. And wherever it is perfectly divisible, then I can consider that it's a factor of the particular number. Am I right? So 1 is perfectly divisible or not? Like 25 divided by 1, it's done. So we have one factor actually. Can you divide 25 by 2? 2 no. 3 no. 4 no. 5 yes. So we got second factor. So like this, what you have to do is you have to keep on counting the number of factors, and if the factors are less than 2, then it is a prime number, and if the factors are greater than 2, then it is not a prime number. So guys, is this clear everyone? The very simple and basic logic. If the numbers, you have to keep on checking the number of factors for a given number, and based on that you can write the logic. So here what I'll do is I'll say integer number, one variable, then one variable with the name divider, and one variable with the name factor. Number equals to factor equals to 0, and divider equals to 1. Why? Because I have to start dividing that number from 1 onwards. And I can say printf, enter a number, scanf, percentage d, %, of number. I'm reading the number from the user. Now I'll say while d is less than or equal to number. Means the divider value we are going to start with 1 till it reaches to number. I'll keep on dividing that number by divider value. So I'll say number percentage d, if it is equal to 0, then you can say f plus plus. Means whenever the number is perfectly divisible by a divider, then I'm incrementing the f value. And every time I have to increment the divider value also. Now what I'll do is, I'll say if the f is less than or equal to 2, then I can say printf percentage d is prime, and I'll print the number variables value. And then otherwise I'll say else printf percentage d is not prime, and I'll print the number variables value. Now let me run this program. Semicolon is missing. I'll say number 90. It says 90 is not prime. It's correct. Again, I'll run this. I'll say 11. It says 11 is prime. So everyone understood this? Just let me know. Got clarity on this? Or if you have any doubts, you can ask me at any line number that why I have written this or what is the use of this. Then I'll help you to clarify. If it's clear, then you can confirm in the chat box so that I'll go with the next concept in this prime number program.
Yes, sir.
Yes, okay.
Yes, sir.
Very good. So guys, simply writing programs and generating results is not sufficient in industry. Performance plays very, very important role. So what I'll do is I'll declare one variable within a count, initialize it to 0, and I will check how many comparisons are done. How many comparisons are done to declare whether a number is prime or not. So every time within the loop, I'll increment the count variables value. And here I will say number of comparisons printf slash n number of comparisons percentage d comma count variables value. Okay, and the same thing I'll print it for prime number also, while declaring whether the number is prime. I'll do that number of comparisons. Okay, now run this program. if I enter one number as 1000, how many comparisons it's taking? It's taking 1000 comparisons to declare that 1000 is not prime. Again, when I run this program, and if I say 1097, it is taking 1097 comparisons. That's nothing but iterations. And then it is saying that 1097 is prime actually. So guys, if I enter the number as 10 crores, can you tell me how many comparisons it will take? If I input the number as 10 crores, how many comparisons it will take?
10 crores.
10 crores. So Upender, please tell me, is it a good programming practice to take this much of time to declare that the number is so and so?
No, sir. We need to use another logics. I
Very
think
good,
so.
very good, very good. So it's not about the output. We need to focus on the performance also. Performance plays very, very important role. So let's try to work on the other logic. Can everybody tell me, like suppose if I take one number, like say 20, what are the two default factors for every given number? Is it one and the number itself? Any number you take it. One and itself will be the two default factors. Then searching for third factor and then immediately stopping saying that this is not a prime number. Will it be a good programming practice? Upender.
Yes, sir.
Now what I'm doing, I am start dividing this number from 1 up to 20. Means right from 1 to up to that count, means up to that number I'm doing. But if I start dividing that number from 2 onwards until that number minus 1 actually,
Right. Okay, sir.
then it will be a good programming practice. Am I right? And
Yeah,
whenever the
little
number
bit.
is divisible, then you simply stop it by giving break. Is this clear? Let's do it. Let's write the program and check practically. Now, the same program, I require one input, divider value. I don't want to count factors, so I'll remove f variable. It's not required. Okay. And I'll say divider value is 2 onwards, because 1 is anyhow the factor of the given number. And I don't want to compare up to that number. I'll say less than number, means 1 less than the number. And whenever the number is perfectly divisible by a divider, then can I declare that printf percentage d is not prime, and I print the number value here, and can I say break? Why? Because if you take one number like 100 and when you divide it by 2, 50 times it will go, then why you compare up to 99? It's time waste. You can simply say break. Now run this. You can remove this. As of now, you can keep comments for this if block. I'll tell you what to write later. Now you just run this program and check. Sorry, the divider value I have to increment it d plus plus, because we have to keep on dividing that number by every divider. And I'll say number as like 200, and it's saying 100 is not prime. Guys, can you tell me, to declare 100 is not prime, how many iterations it's taking? To declare 100 is not prime, how many iterations it's taking? Can you tell me? Guess and tell.
1.
Very good. It's taking only one iteration. So if it is not prime, you're writing here, then there should be one more case. The number is prime. Are you getting my point? I've written like when the number is not prime, it's fine. But what is the stage when the number will become prime? Can you guess? Anyone, can you guess actually? Imagine the number what we have inputted is 7. Imagine the number what we have inputted is 7 actually. It's 7. And you have taken the divider value. It's starting with 2 actually. So is 7 is perfectly divisible by 2? Unmute and you can just keep on explaining me.
No, sir.
No, sir.
Then when you say d plus plus, now is it divisible?
No, sir.
4, is it divisible?
No, sir.
5, is it?
No, sir.
No.
6, is it?
No.
No. So when the divider value is, when it is 6, 6 is less than 7, it will enter into loop. It will check and d plus plus will become actually. Then d will become 7 or not. But it will not enter into the body of the loop actually. Why? Because the condition will fail. Means at last, when the d becomes 7, then the loop will break. So can I say, whenever the divider value matches to the number, then it is a prime number? Guys, tell me. Whenever the divider value matches to that number, then it is a prime number. Can I say like this? See, when the d is equal to that number, okay, equal to the number, then I can say it's prime. And else you can say number is not prime. So you need not to write here. You can simply break it actually. And both messages you can write it here in the if block. Now let's see how it works. I'll say 100. Triveni, is this clear? You said like number of comparisons are 1. Now understood?
Yeah, sir.
Okay. Now I'll run this program once again and I'll say 97. Is it prime or not? You tell me first. Is 97 is prime? Once check.
No, sir.
It's a prime number. 97 is a prime number. Now can you tell me how many iterations it will take to declare the number is prime? Anyone, can you guess? It will take 95 comparisons to declare that 97 is a prime number. So do you think that this logic what I have written has a little bit improvement than the previous logic for point number 1? Do you think in some situations the logic is super powerful, in some situations still we have to improve it? Am I right? Just let me know in the chat box, or you can unmute and tell me. And let me know, have you understood this particular logic or not? Have you understood this logic or not? Like this if conditions, why I have written
Sir,
it? Yeah.
why you take d equal to 2, sir?
Why I'm taking d equals to
2.
2. What is the definition of a prime number, Triveni?
The number is divisible by 1 and itself.
Itself. Then by leaving those two numbers, 1 and itself, if you start dividing it from other numbers, and if the remainder becomes 0, then can you immediately declare that it is not a prime? Means there is a number called 25. So what are the two factors for this number? Can you tell me?
125.
125. So is 25 is a prime number?
No, sir.
Why?
It is also divisible by 5.
Very good. So can I say 5 is the third factor for this?
Yeah, sir.
So when we know that every number is divisible by 1 and itself, you don't divide with this. You don't perform division with these two numbers. You start dividing the next to this one, that is 2 actually. And you divide up to this less than number, means up to 24 actually. And whenever you get the next factor, means whenever you get the third factor, because anyhow two factors are there actually. Whenever you get the third factor, then you stop the process, come out of the loop, and declare that it is not a prime number.
Okay, sir.
Now how this logic works, I'll tell you. See, you said enter a number, I said 25. Okay. What is the D value at this stage?
2.
2. Is 2 is less than 25?
Yeah, sir.
Very good. It will enter into body of the loop. Okay. Is 25 is perfectly divisible by 2?
No, sir.
No. Then D plus plus will takes place. D will become 3. Is 3 is less than 25?
Yeah, sir.
Is 25 is perfectly divisible by 3?
No, sir.
D plus plus. What is the next value? D value?
4.
4. 4 is less than 25?
Yeah, sir.
Very good. Is 25 percentage 4 is 0?
No, sir.
No. D plus plus. D is 5.
5.
Is
5
5
less.
is less than 25? Yes.
Yeah, sir.
25% is 5.
Break.
Break. Then immediately it will come here. Can you tell me when the control came out of the loop, what is the D value?
5.
5. Is D is equal to number?
No, sir.
It will come to else part. It says it's not prime.
Okay, sir.
Understood?
Yeah, sir.
Very good. But I want to say that when you enter 1000, how many iterations it will take? Only one. Why? Because whenever it is divisible by 2, the loop will break. Is it a good performance or bad when you compare with the previous logic? Is it a
Yes,
good?
sir.
Okay. Now again you tell me how many comparisons it will take. Can you tell me?
1095.
Very good. 1095 comparisons it will take it because like 100 itself we are leaving now. So can I say in some cases this is performing well, but in some other cases it's not performing well actually. Still we can improvise it. Am I right?
Yes, sir.
So now use little bit mathematics knowledge. Any number you take it, it has two factors. What are those two factors? The default two factors. What are those? Can I say 100 itself? Can I say guys 100 itself are the two default factors of any given
Yes, sir.
number? Now tell me where can I get the third factor? Can I get in between half of that number? Means any number you take it, I'll get the third factor within half of that number. Will you agree with me?
Yes, sir.
If you say 25, what is the half of 25? 12. What is the
2 and a half.
12 and a half? Okay. Let's consider only the integer portion. So it's 12. Now, what is the third factor of 25? Is it 5?
5.
Is 5 is less than 12?
Yes, sir.
Okay. So now what I'm saying is, why you are checking up to D less than number, why don't you check D is less than or equal to number by 2? Understood everyone? So still I'm improvising my program logic or not. Instead of checking till number minus 1, you check till half of that number. Triveni, understood this?
Yes, sir. Understood.
But there is a problem here in if condition. Can you tell me what is that problem? There is a problem with this if condition. The divider value will never reach to number.
Number by 2.
Number by 2, but we won't get the perfect result. Means this if condition will not work fine actually. So in these situations, what we have to do is we have to work with flag variables. I'll say E is prime. Any variable name you can take it. And initially I'll say it's Y. I just kept one character called Y actually inside each prime variable. And whenever the remainder is 0, I'll change the is prime variable status to n actually, and then I'll break it. Now I'll use this status variable is prime is prime. If it is equal to y, then I'll say it is a prime number. Otherwise, it's not a prime number. Listen carefully. Initially, what is the status of is prime variable? What is the status? Is it y? Is it y?
Yes, sir.
When it will become n, can you tell me? When it will become n?
When the number is exactly divisible by d.
Very good. When the number is exactly divisible by d, then it will become n. And if it is becoming n means what? The number is not a prime number. Am I right?
Yes, sir.
So that is the logic I'm applying here. Now you see, to tell the number 1000 is not prime, only one comparison, that's fine. But to tell that 1097 is a prime number, previous logic, how many comparisons it took? Can you tell me? Previous program.
1095.
Very good. But this time, how many comparisons it's taking?
540, sir.
So is it improvement or not?
Yes, sir.
But I want to still improve it. Can you guess actually how can you improve it? Do you know that any number will get its factor within the square root of that number? You can prove it. Any number you take it, you'll get the second factor. First factor is anyhow 1. The second factor, you'll get it within the square root of that number. Just think and tell me what I said. Have you understood or not? Suppose there is a number called 625. Can you tell me the factors of 625? Factors of 625. 1. After that 1, can you tell me what is the next factor of 625?
5.
5. Very good. Is this 5 is less than square root of that 625 or not? What is the square root of 625? Square root of 625 is it 25? Is it 25? Very good. Very good, Upender. So what you can do is you can include one header file called math.h. Okay. And instead of checking up to half of that number, actually you can check up to square root of that number actually. Up to square root of that number, you can check it out. Okay. And that's it. Now you see this performance of the program. I'll say 1097. And to declare 1097 is prime, how many iterations it's taking? Only 32. So guys, have you understood the whole scenario and the concept? I have explained 4 different logics only just for one prime number program. And from this, can you understand? It's not about the output of the program. It's all about performance of an application that is considered in the market. When you go to any ATM machine, you insert the card, and if the ATM machine is taking some fraction of seconds of time to display a welcome message, you will be frustrated and you will be keep on tapping some keys saying that what happened. When you try to log in into any social media platform, and if it doesn't open within fraction of seconds, you'll be hitting that refresh button number of times. So from this, can you understand that people don't have patience? And if the application is taking longer duration of time for giving a response, then such applications will not have any importance in the market. So performance, results with good performance is very, very important. And that's where your DSA course, data structures and algorithms, will play a major role. So everyone, have you understood today's class? I just focused mainly on the jump statements and the performance kind of concept by taking prime number example. If you have any doubts, you can just feel free to ask me. Is this clear, Upender, Triveni?
Yes, sir. Clear, sir.
Yeah. Yeah, you want that basic method. The first method, Upender, first method you want me to write?
Yes, sir.
Okay, I'll just write it. So I'll remove this status variable concept, and I need to declare one variable called f, because I need to count the factors for the given number. Okay, and I'll start dividing it from 1 onwards. I'll divide uh, up to that number, okay, and there won't be any break kind of thing. We'll say f plus plus, and here if f value is less than or equal to 2, then it's prime, otherwise it's not prime. Let me run this. I'll say 1000. It is taking 1000 comparisons to declare 1000 is not prime. Again, I'll say 1097. It takes 1097 comparisons to declare that 1097 is prime. But by writing 4 different logics, I have improvised from 1097 to 1095, 1095 to 547, something like that. And finally, we took a number of comparisons to 32 actually. Yes, Upender, you can unmute and you can ask me if you have any doubts.
No, sir. Now clear, sir.
Now it's clear.
Yeah.
So see, this program is also correct and it will also give you the answer. But see, if it is your writing just an exam in your college, then it's okay. It will give you the result. But if you are developing an application actually, then performance plays major role rather than simply writing programs. That is the reason one single program I've explained you with 4 different variations actually. At each and every variation, you can see there was some improvement in the performance. So, Triveni and Upender, all clear in today's class? Just confirmation.
Yes, sir.
Very good.
Yes,
Thank you. Thank you. So I'll stop here, and tomorrow I'll continue with nesting of loops actually, like how to write a loop inside another loop, and we'll see a few programming examples in tomorrow's class. Okay. So everyone, please try to finish the first course, Computer Basics, and you upload that certificate in LinkedIn. Once you have done that, then it's well and good. Start with the second course, and I want that second course to get completed as soon as possible, because that will give you the real foundation for the logic building. And even I have explained that how you can draw flowcharts by using a software called draw.io. And I have experienced that so many universities in the US also encouraging students to draw flowcharts by using that particular draw.io software. Okay. So thank you so much, guys, for today's session, and see you tomorrow with more interesting topics as well as programming examples. But It's not only live class. Along with live class, you also have to work every day at least for 2 hours. Okay. So bye guys, and I'll upload the recording in some time. Take care.
Okay, sir.
Bye.